Good day, Miss Joy. Today, you will witness a real-life ellipse scenario where we will also try to find a solution to a problem. But let us get a brief topic recap. Here in this video, I will show you a topic recap, real-life situation where ellipse naturally appears, realistic problems, and of course, the solution and discussion. Ellipse is set of points in a plane in which the sum of distance from two fixed points is a constant. The parts that ellipse has are foci, major axis, minor axis, vertices, co-vertices, directrices, center, endpoints, eccentricity, LLR, length of major axis, and length of minor axis. Now, here comes the problem and the sketch. An elliptical semi-truck cement mixer has a height of 14 feet and width of 12 feet. Meanwhile, a tunnel that the truck should pass has the height of 16 feet and has 36 feet as width. Will it be able to pass through easily? Here, you can see that I divided the measurements into half with the black measurements as the tunnel measurements and the red as the measurements of the truck. As you can see on the bottom part, I placed the values of a squared, b squared, c squared, and also the a, b, and c. Y-axis is the major axis because 14 feet is bigger than the 12 feet. Therefore, the ellipse is taller than its width. So, the longer axis runs vertically. Vertices are 0, 7, and 0, negative 7. 7 is on the spot of y because to avoid confusion, we can place it as yxy. Therefore, 7 is equivalent to y. The same thing goes for co-vertices. It is placed as x, therefore it is placed on the x-axis. To get the endpoints, we will take the values of b squared and divide it to a. And that is equivalent to 5.14. To get the other value, we will just take the value of the c, which is 3.61. For the directrices, we will also take another value, which is the a squared, and divide it to c. We can get eccentricity by dividing c over a. If we get a value lower than 1, it is a ellipse. But if you get a higher value than 1, then it is a hyperbola. By getting the value of b squared, multiplying it by 2, and then dividing by a, we can get the LLR. Length of major axis and length of minor axis is the most basic ones. We just need to remember that the major axis is for the a value and the minor axis is for the b value. And we both just multiply it to 2 and then we get the values. So, going back to the problem, will it be able to pass through easily? The answer is yes. The truck can pass through the tunnel even if they had this difference in height. Because the ellipse height as 14 feet is less than the tunnel height of 16 feet. And the 12 feet as ellipse width is less than 36 feet as the tunnel's width. And just like what I said earlier about the y-axis, the height of 14 feet is greater than the ellipse width as 12 feet. That means that the ellipse is taller than its width. So the longer axis or the major axis runs vertically. This is why y-axis is the major axis. So if we get the standard form, it will be x squared over 36 plus y squared over 49 equals 1. At first, I really had a hard time
understanding the concept and how it would work, and how to do the PT itself. I had a hard time looking for ellipses in real life and thinking of real life problems, and at the same time, I was struggling how to solve it. But then I watched the video you sent by your old student, and I somehow had an idea, and I just started to brainstorm here in my notebook, and I guess I just really understood it while I was doing the task, and I hope I did it right, but I think I did, and I hope I explained it well. This is just a little reflection of how I felt and how I did the performance task. When I was doing the beta, it really came up on me that ellipses are really everywhere. Because while I was researching for examples, I saw so much like headlights, mirrors, and etc. etc. And I just want to also thank you, Miss Joy, because you just teach us to apply our pre-cal lessons in real life and not just in our classrooms.